Welcome back to the Intro to GIS video lecture series. Today what I want to talk about is working with queries and selections in ArcGIS Desktop. So what we're going to do to start today's video lecture is to go in D2L to the lectures page, and I'm going to open up the Queries and Selections PowerPoint in ArcGIS. I also have an instance of ArcMap already up and running, which we will switch back and forth between for demonstration purposes. Queries and selections are one of the more common things that you'll be working with in ArcGIS. So I want you to think of a query as a question and then a selection as the result of that question. So the geographic objects or the spatial features that meet your question criteria would be the selection that results from it. So we're going to learn how to construct queries and also how to manage and work with different selections and turn them into new products or different types of outputs. So to start today's lecture, I want to talk about the three main types of queries. The first type of query is an attribute query, which deals with selecting data based off of information that's contained within the attribute table. So imagine we have a layer that deals with structures or buildings, and we might want to select buildings based on the type of building. So for instance, identify all buildings for me that are single-family homes. The next type of selection that we'll be dealing with is a select by location query, which deals with the spatial dimension. So we might have a buildings layer and a floodplain layer, and we might ask the GIS to identify all the buildings that fall within the 100-year floodplain. And then the third type of query is a select by graphic query, which uses a non-spatial component that we draw on the map to select out features that you can see over here in this picture. So to go into a little bit more detail and to talk about how to deal with selections, we'll go to ArcGIS and add some data. The first thing I'm going to add to the map is a U.S. Census Bureau counties layer. And I'm also going to add a U.S. Census Bureau tracts layer. And what these are is there are two different levels of census enumeration zones that the U.S. government uses to track demographic data. And what we're going to try to do first is we're going to try to identify all of the U.S. Census tracts that are in Virginia. And there's a few steps involved in this process, but it's good because it works you through the process of exploring through the data and then taking the appropriate steps to solve a question. So before we begin any sort of query or analysis, I always recommend that you explore the attribute tables. And so for this very first demonstration, what I want to do is select all of the census tracts that are in Virginia. So the first thing I'm going to do is go to the tracts layer, and I'm going to open the attribute table so that I can look for some piece of information or a field that defines or that might tell us what state that census tract is in. And I can see that there's a state FIPS, a county FIPS, but nothing that directly relates to the actual state name. So even though there's some information that might be an identifier for a state, I don't have everything that I need. So the next thing I'm going to do is go in and open my counties attribute table. And what I'm looking for is this field right here, is the state name field. So this is very helpful, but the thing that makes it difficult is that it's part of the counties layer and not the tracts layer. And in this particular question, we're trying to figure out which tracts are in Virginia. So what I need to do next is I need to compare the two tables to see if there's any sort of unique or common identifier. So what I'm going to do is click on my tracts table, and I'm going to drag it over here so that I have both tables together. Now when I compare the two, what immediately pops out to me is that both of the tables have a state FIPS field. And so it's likely that this state FIPS number is identifying what state that tract is in. So what I'm going to do first is I'm going to sort this field on the county layer so that it's ascending, and I'm going to scroll through until I find Virginia. And I see that the state FIPS code for Virginia is 51. So what that tells me is that I can probably do an attribute query on the tracks using the state FIPS code, and I'll be able to identify all the tracks that are in Virginia or that have the code of 51. So what I'm going to do is I'm going to close out this table. I'm going to go up to the selection item in the menu bar area. This is where you'll go for dealing with any type of selection or query. It's where you manage selections, you can clear selections, you can zoom to selected features, and it's your go-to place whenever you're starting a query. Although, as we'll explore later on in the lesson, there are other places where you can initiate a query as well. But to start off, we're going to go to the Select by Attribute query. So this is the attribute dialog box, and there's a couple things that you want to pay really careful attention to. The first is that you want to make sure that you're selecting things from the correct layer. So in this case, we want to know what tracks are in Virginia, so the layer would be tracks. We're going to be doing a new selection, although as we become more advanced, there are ways to add to selections, select from current selections, and also remove items through a query from a selection. So what we want to do is we want to use these buttons to populate this query box. And what this dialog box allows us to do is to construct basically a SQL query without knowing very much about SQL syntax. So if we look right here, we have this generic statement that says we want to select something from tracks where a certain clause is met. So what we're going to do is we're going to substitute items from these boxes into these spaces in this generic SQL query. So we're going to scroll down and find the state FIPS field, because that's where we're trying to execute the query from. We want to know what state FIPS tracks equal 51. So I'm going to double click on state FIPS. So we're going to select from tracks where state FIPS, and we're going to pick equals, and then since we don't know what all the values might be, we're going to hit the Get Unique Values button, which will populate a list of all the values that we have in that field, and we'll scroll down through and we'll find 51. And you'll double click to get 51 into this dialog box. Now I want you to pay special attention to how there are single quotes here surrounding these numbers. The single quotes identify that this is a string field, and it's really important that you, if it is a string field, that you incorporate these single quotes. Otherwise the query will not work. So all string fields, which are also known as text fields, have single quotes around them. Numbers do not, and field names have double quotes. These are very important things to remember, and if you can't remember them, the easiest solution is to just use the items from this dialog box so that the proper syntax is filled in. So what I'm going to do to make sure that this query works is I'm going to hit Apply, and all of the census tracts that meet that criteria are highlighted in cyan. Now cyan is the default color for identifying places that meet a query, or for showing you what has been selected. So everything that is in that blue cyan color is a selected feature. If you don't like that color, you can go to your selection menu bar item and go to selection options, and you can pick different colors and set different parameters that will help you kind of customize your selection. But cyan is one of the most easily noticed colors, and so there's a graphical reason as to why Ezra has picked that color. Okay, so now I have all the census tracts highlighted in blue that are in Virginia, and so maybe we want to do something with this. Maybe we're working for a company that's in Virginia and we don't care about any of the other census tracts in the US, so we want to only have a map showing the census tracts in Virginia. So what we can do is we can manage this selection and turn it into a new layer, and there are several different ways to do that. The easiest, or the quickest way, is to go over to census tracts, right click on it, scroll down to selection, and we can create a layer from a selected feature. And what that does is it turns everything that was highlighted in blue into a new layer in the map. What's interesting about this option is that it's not actually changing the data, it's simply masking all the other data in the map. So this is actually a temporary layer that is being run, or that is referencing the tracks right down here. And what's being done under the hood, which we can actually see, is there's been a definition query or some properties that have been set to make sure that you can only see the census tracts that meet that specific criteria. So this is nice, but it's not really a permanent layer in the map, and so sometimes it will go away, and there are situations in which you might want to turn your selection into something that's more permanent. So the second method that you can kind of turn a selection into a new layer is to right click on that layer and go down to data, and you can export data, and you can choose to export only selected features. You can export everything in a map, or you can export only the things that have been selected. And notice how this is going to my default geodatabase, and it's getting a generic export name. So I'm going to call this tracks selection. It asks if we want to add it to the map, and you'll say yes. And notice how it looks identical to the selection that we made using the other method. One is just permanent and one is temporary, so it's kind of up to you which method you want to choose, and it really depends on the operation that you're trying to do. Okay, so that's one very simple attribute query. But lots of times when you're working with GIS, things are much more complicated than a single one-line kind of SQL statement. So now why don't we go and explore the table a little bit more in depth and see what sort of information we have in here. So maybe we're trying to identify a place that would be good for someone to go maybe start a family after college. And so we scroll through here and we see that, well, there's actually a median age field. And so we'll maybe assume that most students are graduating between the ages of 21 and we'll say 30 for the sake of this argument. And then maybe we want to be in a place where there's an average household size of maybe 2.5. So we're looking for places where, you know, maybe most of the population has at least one kid, but there's not too many. So we're going to do a query where we're looking for the median age to be between the ages of 21 and 30, and the average household size to be at least 2.5. So this is a little bit more of a complex query than the previous one, but all of the same rules apply. So instead of going up to the selection menu bar item and clicking select by attributes, we're going to initiate an attribute query using a different method. We can also go to the table options and hit the select by attribute button, which basically pops up the same dialog box, but this one deals specifically with the layer of interest, and we no longer have the option to pick different layers. So again, we're going to create a new selection, and we're going to start off where we have the median age, and we want this to be between the ages of 21 and 30. So we have to think a little bit about this. So okay, so we want it to be 21 or over, but under 30. So we're going to use the greater than or equal to button, right? Because you can be 21 or you can be older, and then we're going to hit get unique values so that we can identify whether or not this is a string or a number field. In this case, they do have the number 31 in there. Notice how there's no quotes, which means this is a number field, but again, I can just go in and click, actually we don't want 21, we want 30, or 30, we don't want 31, we want 21. And because we want us to be between that age, we're going to have to use an AND operator to link two small queries or two parts of a queries. So if we want to be between those two ages, we're going to have to use the AND operator. and we're going to again pick the median age, and this time we're going to do less than or equal to, and we're going to pick 30. So I want you to think about the logic between this. We're saying, okay, I want you to select something from the Virginia tracts where the median age is greater than or equal to 21, and the median age is less than or equal to 30. And it's always good to try the different parts of this query to make sure that they work. So I'm going to go in and hit the apply button, and what I want you to notice just happened is we got with the table open, is we got this number popped up which told us that there's 145 tracks that meet that criteria. And so if we want to see the attribute data for only the tracks that meet that criteria, we can click this little blue button, and it will show us just the tracks or just the rows or records that meet that criteria. And we can kind of scroll over, and we can look to make sure that we did this right at the median age column, and if everything has gone okay, we should have only ages between 21 and 30, and everything looks pretty good. Now I want you to be very careful about whether or not you use the AND or the OR operator, and we'll go into more detail on that a little bit later, but it's a very common mistake where people use one in the wrong place. So I need you to think logically about it, and we'll have further exercises on that. So now let's go back to the Select by Attribute dialog box, and notice how that information is still in there. So now we're going to move on to the second part of the query, where we want the average household size to be greater than 2.5. So we're again going to use the AND operator, and we're going to go in here, and we're going to find average household size, and we're going to say greater than or equal to, and we'll hit get unique values. And again, this is a number field because there's no single quotes, right? And we'll look for 2.5, and there it is. So we'll click on 2.5, and we'll hit apply. And I want you to notice how the number of selected records went down to 86. So when we added that second piece of information in there, we further refined our selection, and now we're down to 86 census tracts. So now I'm going to close this table, and you can actually look here and see the geographic distribution of places that meet those criteria. And so what I'm going to do again is I'm going to turn that selection into a new layer, maybe so that I can symbolize it better or see what's going on in a different way. So I'm going to go to Selection. I'm going to hit Create Layer from Selected Features. And so now I have a selection that is based off of my selection. What I'm going to do is I'm going to go in there and I'm going to turn that red so that I can see it a little bit better. And I'm going to clear all the cyan colors by going to Selection and hitting Clear Selected Features. So now we can see that most of these places that we might consider good for starting a family are located on the east coast of Virginia, and many of them are concentrated near metropolitan areas. So we have out in Northern Virginia around DC. This looks like it's probably over near Harrisonburg. We have Richmond, and maybe even Virginia Beach. And so if we wanted to get a little bit more detail or a base map to help us reference where these spots were, we could go into ArcGIS Online and do a search for a base map. One that I like to use quite frequently is the National Geographic base map. So we type in National Geographic, run a search, and we look for the one that has the add option, which is right there. We click add, and then I'm going to turn off my tracks selection so that I only see the places that are of interest. And immediately what pops up that's kind of neat is there's a spot over near Blacksburg, which actually happens to be near where I live. In addition to that, we have all these places outside near DC. So over near Dumfries and let's see, Fairfax and a couple other places, Arlington, And then, as I mentioned before, it looks like Richmond popped up as a point of interest, and in Virginia Beach. So that's one example of how we can ask questions or do queries using information in the attribute table to highlight areas or select geographic regions that are of particular interest or meet certain criteria. And so now we'll move on into another example of how to do similar types of selections. So instead of census tracts, I'm going to go in and I'm going to scroll down to a geodatabase that's for Radford City. And in this geodatabase, there's a layer that represents different types of zoning. So zoning has to do with the type of activity that one is permitted to do in a certain region. Now, just a minute ago, we were looking at a map of Virginia, and now we've changed our scale and we're going into a more local scale, so we'll be looking at just Radford. And for many people, you might not know exactly where Radford is. And so one nice trick to zoom to geographic features of interest is to right-click on that layer, and you can hit Zoom to Layer. And this will center your map on that particular area of interest. So it's a very nice trick to help you navigate. Now we're looking at this map, and it again doesn't make too much sense. We see a bunch of polygons that don't really have much meaning. So again, the first thing that we want to do is we want to go in and open the attribute table so that we can explore what's going on. And so in this situation, we can see that there's a zoning type field, which, if we looked on the internet, relates to the type of land use activities that are permitted to be going on in that particular area. And so what we're going to do is we're going to symbolize this layer based on the zoning type, so that we can kind of get a little bit of a better perspective as to what's going on in that area. So we're going to go click on Layer, go to Symbology, click on Categories, and then we're going to add the values. Something has happened to that. Let's try a different zoning layer. There we go. We'll use Z code. Go to Properties, and we'll hit Symbology and Categories, and we'll add all the values from the Z code field, and we'll pick a color palette to display them. And so now we can see all of the different types of zoning designations that we have within the city of Radford. So for instance, over here we have the University District. B1 is these areas that are in green, and so we can reference over in the table of contents to identify what color means what. But in this particular exercise, what we want to do is we want to query out all of the places that have a zoning code type of CD. And CD stands for Conservation District. So these are protected places within Radford. Many of them are actually where parks are, such as Bissett Park or Wildwood Park. So again, we'll go up to Selection, and we'll hit Select by Attributes. And instead of using tracks, we will pick the zoning layer, and then we will go to Z code. We'll hit equals, get unique values, and we'll pick CD. I hit Apply, and then OK, and all of the places that have a zoning code that relates to conservation districts have been highlighted. If I want to turn this into a new layer, I can right-click, go to Selection, and Create Layer from Selected Feature. And that's done. Now we can turn that off, make that green, and now we've basically created a map showing all of the protected land that's in Radford. Pretty easy, and it's very important that you become comfortable with selections. Now, if we go into the selection options that we access by right-clicking on a layer of interest, there are more tools in here that we can use to kind of manipulate and manage selected features. So I'm actually going to go back to our original zoning layer, and if I right-click and go to Selection, you can see that we can zoom to a selected feature. So if I moved my map and I wanted to zoom to something that we had picked, we can go Selection, zoom to selected features. It's very handy. Say I selected conservation districts, but I wanted to create a layer of everything that's not protected. I could go to switch selection, right? And what's that's done is it's given us the opposite of our previous layer. So now we see all the areas that are not protected, right? And there, are several other options. So we can select everything on a map, and we can also limit what sorts of layers that we're allowed to do selection operations on. So, for example, there's a very simple way of selecting features, which is using the Select Features tool. So maybe I wanted to go in and manually select something. I could grab this tool, and I could click on a particular area of interest. It highlights that, right? And it also highlights that record in the table so that you can see what sort of information is related to that. If you hold the Shift key, you can select more than one thing on the map. Or you can drag a box and select all the features that are underneath that. But sometimes you'll run into situations where you don't want to select all of the features in a certain area. So if you go up to your table of contents and you scroll over to the fourth button, there is a list by selection. And if you go into here, this gives you the opportunity to either enable or disable the selection kind of functionality of different layers. So maybe you want to only be able to select one layer on a map. You would go in, you would deselect all the others and select one. And that would kind of give you a little bit more flexibility over how you deal with selections. Okay, so what we've covered now is we've covered how to do an attribute query, how to set some of the properties for your selections, how to create new layers from selections, how to export data, and also how to construct a complex query that has more than one more than one criteria. So what we're going to look at next is how to do spatial queries, which are a little bit different than attribute queries, but they still basically do the same thing. They select information based on some sort of criteria. So what I'm going to do next is I'm going to go in and I'm going to add a buildings layer from my Radford geodatabase. So here we have buildings. And what I'm going to do is I'm going to turn on my conservation districts, because we're going to ask a question here which is a combination of an attribute query and a spatial query. So I want to identify all of the buildings that are within a conservation district, and you can kind of visually see where you have conservation zones and where there are buildings. But we don't really have a good feel for the number of buildings that actually fall within that, and it would take a really long time for us to go through and count all of those buildings. So a spatial query would be much more efficient and a much more accurate way to identify the number of buildings that exist within a conservation district. So what I'm going to do is I'm going to go back to the selection menu bar item, and I'm going to pick the Select by Location option. And this dialog box again asks us to pick a feature that we want to select from. So we want to select features from buildings, and we want to see which ones are interacting with our zoning selection 2, which is conservation districts. So our source layer would be zoning selection 2, and we want to find all the buildings that are completely within. So we want them to be totally within the conservation districts. So I'll hit the Apply button. And it looks like we've selected all the ones that are not within because we used the wrong source layer. So if we go back here and we turn on zoning selection 2, that's all the places that are not conservation districts. So what we'll do is we'll turn that off, and we'll change this to zoning selection 1, and we'll re-hit Apply, and we can see that all of the buildings that fall within the conservation districts are highlighted cyan. If we want to get a count for the number of those, we would right-click on the buildings layer, open the attribute table, and we can see down here that we have 36 records selected. If we click on the blue little button there, it gives us only those selected records. And again, by right-clicking on this and going to Selection and Create Layer from Selected Features, we can create a new layer that is buildings that are within the conservation district. All right. Now, there are more complex forms of select by location queries. They may incorporate some sort of distance component. And so if you actually think back to the Dinosaur National Monument Lab, we were dealing with IRIs that maybe were within a distance of a certain boundary or that fell within a certain area. And you can do all of those very same things that we mimicked with the buffer tool in this select by location dialog box. And so let's try another query where we want to identify all of the buildings that are within 100 feet of a conservation district, which is similar to what we did with the buffer in the Dinosaur National Monument Lab. So I'll look through this list to find a topological or spatial operation that's going to do what I want, and I see here there is are within a distance of the source layer. So I'm going to click that, and then I'm going to type in 100, and we'll pick feet. And to make sure this sounds right, I always like to read it out loud. So I go, okay, I want to select features from buildings that are within 100 feet of the zoning selection. So I'll hit apply. And we'll turn our buildings layer on because it was previously off. And we see that we have even more records selected. So over here we can go in and we can say, hey, look, oh, well, some of these buildings did not show up in our very first query. I wonder why that happened. Well, remember that we picked are completely within. And so maybe that wasn't an appropriate selection method for this sort of operation because some of the buildings are intersecting the layer, some of them are maybe really close, and so on. So when we use the 100-foot kind of buffer zone, we picked up more records. And so you really kind of need to think about the question that you're trying to answer and how those different geographic objects relate to each other. So for instance, if we were dealing with floodplains instead of conservation districts, maybe it's very important to know if any section of a building is within the floodplain. So we would not pick the are within option. Instead, we might pick the intersect option because that would be a more appropriate spatial selection. So I encourage you to explore this and try to utilize it as best as you can because it really does make a lot of spatial analysis options or operations much easier because you don't have to run a series of tools. So one of the things that typically replaces is the buffer operation. Okay, so now we're going to move on to the third type of query, which is far more simple than the previous ones. And so what I'm going to do is I'm going to go back over here to my catalog, and this time I'm going to add a parcels layer. So parcels are basically pieces of land or lots that are represented by polygons. And remember that polygons are vector-based information. Another kind of important thing I need to mention is that these queries only work on vector information. So if we're dealing with raster data, you cannot run spatial or attribute queries. So the last type of selection operation or query operation is the select by graphics operation. And to run that, you need to make sure that you have graphics on the map. So if we go over to our selection menu bar item area, we see we have the select by attribute option, the select by location option, but select by graphics is grayed out. And that's because we don't have any graphics. Graphics are different than layers in the sense that they're really non-spatial data. They're just drawings that we overlay on top of the map. So by default, they do not show up in the table of contents. It's only something that's visual. So to get a graphic on the map, the first thing we need to do is right-click in the toolbar area and add the drawing toolbar. I like to dock my toolbars, but you don't have to. And then I'm just going to draw a simple polygon over an area of interest on the map. And then notice how that polygon is highlighted. When that's highlighted, we can go over to the selection menu bar item, and select by graphics has now become enabled. If that is not highlighted, it goes away. So you can have multiple graphics on the map, but to actually do the selection, you have to highlight the one of interest. So we go over here, we go to selection, I select by graphics, and all of the features, and I'll just delete this graphic so it's not in the way. All of the features that intersected that graphic become highlighted. And again, we can turn that into a new layer by right-clicking on it, going to selection, and creating a layer from selected features. Really simple and a great way to customize your maps or limit your data to a specific area of interest. Okay, so now what we're going to do is we're going to jump back into that PowerPoint and review a couple of the key topics or key things that we've talked about. So just to reiterate, we went over the three main types of queries. We talked about select by attribute, which deals with tables, select by location, which is a spatial query, and select by graphic. Now there are a couple things that I want to remind you of, or that you really need to remember about the select by attribute box or dialog box. It is very picky and it wants things to be typed in perfectly. So I highly recommend that you use the buttons instead of type them in yourself. You will get errors, but you need to just keep trying, and sooner or later you will identify what it is that you've done wrong, and almost always it's a typo or a failure to capitalize something or use quotes or something like that. So remember that any sort of string field, which is basically a text field, requires single quotes. Very important. Numbers do not require quotes. Field names have double quotes. If you hit the Get Unique Value button, it will always show you the correct format. And always pay attention to what you're typing into that box because you need to have the correct syntax. There are three things that you need to execute any query. You have to have a field name, you have to have an operator, and you have to have a field value. So if we look at the example here, owner is the field name, the operator is equals, and the field value is Smith. In a different example that deals with numbers, we have a value field, greater than is the operator, and 150,000 is Smith. So what we're maybe doing here is we're querying that parcels layer where we're trying to identify places that are owned by Smith and that are over $150,000. Now we could run these two queries independently, right, and isolate the places that meet these criteria, or we could do it in a complex query like we did earlier with the Virginia demographic information. So when you do complex queries, you really need to think about whether or not you should be using an AND or an OR. So for an example of how this can make a difference, I want you to consider where we ask for the owner to equal Smith and the value to be over 150,000. What this results in is parcels that are owned by Smith and that are also greater than 150,000. Whereas alternatively, if we do the query and we use the OR operator, we're getting all the parcels that are owned by Smith or that are greater than $150,000. So sometimes it's confusing because the way we talk about things, if we look down here, we're using the OR operator, but in the English language we might use AND. So the second query will result in far more records because there could be properties that are owned by Smith, but they're less than $150,000. We could also get properties that are not owned by Smith but are over $150,000. So I want you to think about another example where we might, and I'm going to jump back into ArcGIS Desktop, where we might want to use the counties layer, and we probably want to select all of the counties that are in the New River Valley. And for those of you who don't know about the New River Valley, it makes up it's Radford City, Montgomery County, Pulaski, Giles, and Floyd. And so what a lot of people want to do is go and do an attribute query, and they want to use the AND operator for a query of that nature. And that's wrong, because a county cannot be Radford and Floyd. It's one or the other. So what we would do to select all the counties in the New River Valley is we would go in and we would find the county field, and I'm going to have to reference the attribute table. So we have name, which is the county field. Okay, so we'll go up here, we'll go name, and we'll say equals, and I'm going to hit get unique values to identify the type of field. We see that it's a string, and I'm going to just put in a single quote, and I'm going to type in Pulaski, and end the single quote, space, and it's or name equals single quote Radford. Oh, and I just did a double quote, so be very careful. Single quote there, and again we'll do or name equals single quote Floyd, into single quote, and then again we'll hit or name, we'll do equals single quote Giles, and so we have Pulaski, Radford, Floyd, Giles, and then lastly we'll do or name equals Montgomery, in single quote. And if you want to double check this to make sure everything makes sense, you can hit the verify button, and it kind of gives you some help as to whether or not you executed a query that will work. And so now I'll hit the apply button, and we can see that, well, I've highlighted some of them, but not all of them, so something's going on. I've actually missed Montgomery, and I've also missed Giles County, so I have to go back and look at my query to see what I've done wrong. And just like I mentioned, I have an error with a double quote there, so I'll correct it to be a single quote. And again, for Montgomery, I start it with a double quote when it needs to be a single. And so now I'll hit apply, and my query has executed correctly, and again I could turn that into another layer. Now if, for instance, I had used the AND operator in here, it would basically be implying, or the logic would suggest, that all of these places are, well, we would say Pulaski is Giles and Radford is Montgomery, and so on, and that doesn't work. So if we hit the apply button, you can see that there are no results. So you need to really take some time and think about whether or not you want to link queries together using the AND or the OR operator. It's a very common mistake, and I assure you that you will make it. Okay, so now let's move on to the select by location query. Just remember that the target layer is what you want to select the data from. The source layer is where you're going to be applying the selection criteria to. So when we talk about the type of spatial selection, that is in reference to the source layer. So we do not select features from the source, we select features from the target. So in this situation, we're trying to select structures that intersect the Richmond 100-year floodplain. So again, I always suggest that you say these things out loud, and remember that when you use selection methods that incorporate a distance parameter, that is going to kind of mimic the buffer operation. And the last thing that I want to go over is just to remind you that when you do the select by graphic, that you must turn on the drawing toolbar, and to enable the tool you need graphics that are on the map, and you need to have them selected. So the tool only works off of selected graphics, and also just remember that graphics are not layers, so they are non-spatial elements that you draw on the map, and they will not show up in the table of contents. Other than that, we've covered most of the things related to managing selections and doing queries. So after watching this video, I would like you to move on to the next lab and try to execute some queries on your end. That's all. Thank you.